So hi everyone. We actually did an edition of this meetup in Delft, and we figured we wanted to say something about artificial intelligence. I was not supposed to be a speaker then, and one of my colleagues asked me if I knew someone who could give an introduction into artificial intelligence. So that ended up being Ruud. He's actually my brother, so now we happen to be on stage together, which is a fun thing for me to do. He knows a lot more about the insights of machine learning. I actually want to show more about how we are using artificial intelligence in web applications that we're building here at the Voorhoede. So what we basically already had today was more of a deep dive, and if we talk about artificial intelligence, what is actually the technology behind it, so machine learning, deep learning, neural networks. But what I would actually like to talk about is the layer that we can put around artificial intelligence. So thinking about the psychology, the privacy, the ethics, and the user experience around artificial intelligence. To give an example, this phenomenon is called dooring, so dooring a cyclist. And there's different ways in which you could tackle such a problem. So this cyclist could bike a bit more to the right, more in the middle of the lane. Or, to be fair, it's in the UK, so it makes sense that he's on the left. There's, like if we change lanes, we have a blinker. We could make sure that the moment that you start opening a door, it makes a sound or does something, so that we let cyclists know that the door is opening. There's something that is called the Dutch reach. I don't know if you know it. So if you get out of the car, don't do that with your left hand, but use your right hand so that you look over your shoulder and check if there's a cyclist there. So those are things that we could do. But finally, you can also tackle this with artificial intelligence. And Tesla is doing such a thing. Someone on Twitter said to Elon Musk, I've been hit by a door. Couldn't you make sure that the camera that you have on the sides detect whether there's a cyclist coming, and then keep the door electronically locked so that I can't door a cyclist? So they're doing that in one of their next releases. So that solves one problem, but maybe that introduces a new problem, namely that the person that actually wants to get out and it maybe has a bit of claustrophobic tendencies actually feels like doesn't open what's happening. So all of a sudden you create a new problem for which you need a new user experience to solve. So basically, my point of this being is that with artificial intelligence, we can both create new experiences, but artificial intelligence might also require us to come up with new user experiences. And today I want to show that in two of our projects, which are the Plastic Soup Servers Pickup 10 app and a Mental CLO app. And they're built using Google Vision and AutoML. Those were also things that were already passed in previous talks. First, before I dive into these projects, I want to show a bit about the state of WebML in the browser. Because what we mainly do here is we build web apps. Web apps run in a browser, which run on a platform or on an operating system, which in their turn run on hardware. So that hardware may have CPU and a GPU. GPU is more performant when it comes to running neural networks. There's also such a thing as a TPU, a tensor processing unit, that is optimized to run neural networks. But we depend on what the platform then actually exposes to us. And basically all operating systems now have their own integrated software that are optimized to run neural networks, specific on iOS or on Android. But for us, being web app builders, we also depend on what the browser exposes. So for us it becomes a question, are there actually browser APIs that expose this on the web? So basically the state is that there is a concept for WebML. There's a WebML W3C working group for WebML that are trying to make machine learning a first-class citizen on the web, so that eventually it should be as easy as creating a new neural network context, training that, creating a model, and then you can use that model for your predictions. But this is all concept, and currently it's not there. It's nice that there's a working group there, so that means it's probably not going away and we'll get it somewhere in the future. But right now that means that whatever is on the device, we can't really do most things with it as web app developers. So what we have to resort to is doing the same thing, but then in JavaScript and probably using libraries for it. We can, but it can be heavy things to run and download into the browser. So what we actually typically do is leverage AI services in the cloud that might actually, like some of Google's services already use these TPU chips on the edge, and we can leverage that, use those APIs in our products, and in that way leverage AI in our web apps. And that's what we did for those two projects. So the first one being Pickup 10. Pickup 10 is a game as a web app that for which the plastic soup server wants to fight plastic litter. So what we have to do is detect plastic litter in pictures taken on the streets, and for that we ended up using Google Vision. Google Vision is actually a collection of pre-trained machine learning models for image recognition. That means that we basically don't have to do anything and can use it out of the box. So I can give a quick demo. I took this image from the meetup page, and I can go to the Google Vision page and have a little demo here. Ironically, I have to say I'm not a robot. And then finally, this is what it tells me. It's able to detect faces, what kind of expressions those have, so probably joy. It can also tell me there's a lot of men in the audience, some not sure, but in any case, a lot of men, and some lighting. It detects context from other images, so it's yes, it's not a meetup, it's an event community, so that's good. Other web-related searches in here. It detects text in the image, so even the things here on the t-shirt. So these are things that we can then use in our web apps. I first heard about the Google Vision API at an Apogee conference in London, and we came back and then we sat down with Marijn Tinga. He's the plastic soup server, and he had a campaign in which he wanted to fight plastic litter. And we figured that this was actually technology that we could use to detect that litter in images and maybe even faces, etc. So we went to work. We had a hackathon here to see if we could come up with a concept. And at the core is this Google Vision API that you send a picture and returns that information that I just showed. But around that, we came up with a user experience, like how do we introduce people with a landing page about how this works, how to take the picture, what should happen while they wait, and then they end up on a leaderboard, invite their friends, etc. But at core was this Google Vision API. And this was the first version that was the result of the hackathon. So that's the homepage explaining how it should work, accessing the camera, taking the picture, and then you see that I'm on a roof terrace using flaky Wi-Fi. So this actually takes some time to recognize. So this is basically one of our problems, right? That we want to create a user experience around this where you can just point, click, and see like it's in there or not. Whereas here, I might actually have to wait for half a minute. And then we did a campaign around plastic and it says, yes, I found a glass bottle. So, but at least this gave us an idea that we could make something like this work. So that was the result of the hackathon. And from there, we had to improve this to actually make sure that it was a smoother user experience. So one of the things that we changed is rather than uploading the image directly to Google Vision, which ended up being very slow, to upload the image first to an image service, in this case Cloudinary, and then use an optimized smaller image of which we send the URL to the Google Vision API. And there, that's actually very convenient. We used a Lambda, a cloud function, in which Google actually offers an NPM package, the Phishing package. I can create my image annotator, and I can ask for face detection, logo detection, the web detection that I showed, and do something with that. And if you're not using the package, you can also use REST, and then it's a regular post request with the same information. And then we get back the information that we had before. And from there, we started putting a user experience around that. One of the first things that we did to try to explain to the user what's happening. So we tell them, you take a picture of the letter, and then the magic happens. We try to identify what's in the image, and based on that, we go to the people in power to make sure that they change policy so that this happens less. And the other thing that we had to fix is those labels. So basically now if we get back glass, we replace that by plastic. And that's so, and sometimes give back plastic, but it very often return glass. And we have some challenges like plastic fantastic. You have to get plastic and have that multiple times. That's what we corrected there. We did it in the cloud functions. That was that annotation magic. And with the logo detection, we could actually do a branded and busted around that. So we could see that there's a lot of Coca-Cola in there, and the plastic subserver can go with that whole pile of data, can go to Coca-Cola. So like a lot of your litter is ending up here. Can you do something about that? So that's why we did this campaign. And finally, what we could do with the face detection is that you would get a Lilfi, that's a litter selfie. That was a ×2 multiplier. So that was part of the game, but we also had a page where you had all your pictures so that you could delete them again and could share them with your friends. And we ended up finding out that you never had to make an account for this, you didn't have to register. So normally we wouldn't have an avatar, but since we had this challenge in there on your, basically your pics page, we could also all of a sudden give you an avatar because we had this face detection in there. So it's actually nice for us that we can play around with these things as well. And for this, most things we got out of the box because we could just leverage Google Vision as it was. This is the full end result. It's still just a regular website with a regular URL. It's completely off topic, but we like to turn everything into a progressive web app here. So also this one, you can put it on your home screen so that it opens full screen, feels more like an app, but you don't have to install it through the stores. You could take a picture. We make sure that we show the picture already here as a loading indicator because we still need some time for the recognition. And then finally, here you get to see what you scored. And that's it for the pickup 10. Somehow we were trying to make sure that there was as little litter in the world as possible with this. But this ended up with Mentos coming to us saying we would also like to use, see if we can use this for a project. And they are in the top 10 of people that create plastic litter in the world. So, but for us this was a very nice technical challenge. They said like, if you can do that, we have on the candies in the Mentos roll, we put illustrations on there, and those illustrations are for people to do challenges in the real world, like piggyback riding, high five moments, other silly social things, so they promote social interaction in the real world. But we wouldn't be able to use Google Vision for this as it was, because at best it would tell us that there was candy in the picture, but for sure it wouldn't tell us the image that wasn't there. So we needed something else for this. We tried different things in the early stage, including creating our own TensorFlow model, which was quite hard to do, whereas at the same time we were also using Google AutoML And that ended up being the simplest solution for us. Because the difference with AutoML is, like Ruud was also showing, is you can train your own model simply by providing your own data set, and the result is a trained model with a REST API that we could again use in our web app. And this time we had to do the training ourselves. So basically that means just putting in, taking a lot of pictures. So there, just for the prototype, there are 1,300 pictures in here. So I think one of the first things that my colleagues did was actually make an app so that they could quickly take a picture, label it, and that it would end up in here, because otherwise our hourly rate is much too high to take 1,300 pictures and put them in AutoML. And here you can see the different pictures taken with different phones and different lighting, etc. With the same challenge, and you do that for the different images that you have, or the different illustrations on the candy. And we even trained it for what it's not, so that we could also say, maybe turn it around, because maybe there's an icon on the other side. And this ends up giving you a confusion matrix. So here we can actually see how confident AutoML is that it would give us the correct answer when we ask it to predict an image that's not in the data set. And so here you can see outliers where it predicted that there was a smile icon, whereas it was actually Ella's friend. And as was also mentioned, what's actually behind there is a bit of a black box, but it gives you tips in what you can do to improve it. In our case, it was simply add more pictures until we had a better confusion matrix, and we were confident that if we would show it something, it would be quite accurate in predicting what was on the candy. With this, we could actually put this into our web app, but then we ran into a similar issue as we had with Pickup 10, is that when you have images with your high resolution phone camera, you can actually get a 5 or 10 megabyte photo, and those large photos have to be uploaded to the server continuously, because we can't run it in the browser, which means we devour your data plan, but those big pictures also take a long time to do the recognition on the server, so we needed something to optimize those images. One of the first things we played around with was trying to see if we could do resizing in the browser. So use a canvas element and simply size the photo down and reduce the image quality and send that up. And we could actually already greatly reduce the file size. So you see it going down for 200,000 to 2,000. So that's a factor 100, and we were still able to recognize images there, and we could just play around with it. And we actually also found out that if we have lower resolution images, that also the whole training of the AutoML model went much faster. Then what we also figured was that you could basically crop the image to only the part that we need, because we only need to have the candy in there, and we don't really care about the rest. But you typically need AI to figure out where it is in the image, and we didn't really have something in the browser, cross-browser available. We tried a library called Smart Crop.js. It didn't do great work in how much it would crop off, but we could already see that it again saved some of the file size, and especially that the predictions became much more accurate, because there was simply less noise in the picture. So since we couldn't really fix this any further through technology, we ended up helping out the user. So that's Declan. I actually stole his slides for this part. And he's training the model there and trying to see if it works. And we figured that just by putting a circle over the camera area in the browser, we could actually tell the user where they should put the candy, and then we could simply crop around there. And with that we eliminated much of the noise and much of the file size, and ended up with quite fast image recognition. So that's basically this one. So of course, again, it's just, they also said we want a regular web app because we're using this in a campaign. There's going to be a QR code or a URL on there, so you should be able to just navigate there. We don't want them to have to install something through the store. Again, we want to make it a progressive web app, so you can still install it and start it up from your home screen, just so that it's again full screen with some extra functionality. But the core here is again the scanning. And this time we didn't go and switch to your camera, but actually use the camera inside of the web page so that we could do that overlay. And you see that this is actually kind of fuzzy as an image. I would hardly be able to make out what it is. But the model was actually very accurate constantly in being able to predict it for all the different ones that we had. This is not the final product. This is what I think what Declan came up with all the giffies in there, just to show what we could do. And I think this has to be a back and forth with designers also in what do you want to use after this. There were actually designers who did a design sprint before this, figuring out how it should happen. This is een borrelnootje. So this was one where we had to check, like, shouldn't know what's happening. But this was, you need a back and forth with designers with this. They did a design sprint showing how this should work, and it was basically, I have my phone, I see it there, I do this, and tada, it's there, I do the challenge. And as you see, we actually need time, because that would be a video with many frames, just like with the audio. And then we would have to send all those frames to the server. So instead, we still have a manual scan button. We could do that when you hold your camera steady or whatever, but those kind of things we would have to figure out with the designer and see what technically would be feasible. But we were quite pleased actually what happened with this, and were able to show that to their whole marketing department, so that all the other marketeers could also come up with things like how they could put this in any campaign. So that's it for me. Thank you for your time.